the ground whispers. Beneath us, unseen forces begin to awaken. In the American West, two titans lie dormant, Mount St. Helens, cloaked in snow, and the Yellowstone supervolcano, a vast caldera of power. Lately, Mount St. Helens has shown signs of life, sending ripples through the earth. Could these tremors, minor to the planet, awaken something far more formidable, capable of unleashing catastrophic power? Could Mount St. Helens, with its fiery outbursts, somehow rouse the sleeping giant that is Yellowstone? Mount St. Helens, once a pristine cone, now bears the marks of its violent history. This magnificent peak in the Pacific Northwest has a story as dramatic as it is captivating. Its perfect symmetry was obliterated in an instant, leaving a vast crater that stands as a stark reminder of nature's raw power. In 1980, the mountain erupted with a force that reverberated around the world, forever altering the landscape. The eruption was one of the most significant geological events of the 20th century, sending ash and debris high into the atmosphere and impacting weather patterns globally. The once tranquil environment was transformed into a scene of chaos and destruction. Now, decades later, a new period of unrest has begun. The mountain, though quieter, is far from dormant. Signs of life are returning, with new vegetation sprouting amidst the ash and rock. Yet beneath this veneer of calm, the earth is stirring once more. Earthquakes, small but numerous, rumble beneath the surface. These tremors, though minor, are a clear indication that the mountain is not at rest. Each quake is a reminder of the immense forces at play beneath the Earth's crust, hinting at the potential for future activity. Scientists monitor closely, watching for changes in the mountain's behavior. Equipped with the latest technology, they track every movement, every shift, hoping to predict what might come next. Their work is crucial in understanding the mountain's moods and preparing for any eventualities. The public, captivated by the power of nature, wonders, what does this activity mean? Visitors flock to the area, drawn by the allure of witnessing nature's raw power firsthand. They stand in awe, contemplating the mountain's past and speculating about its future. Is this a prelude to another eruption? The sight of steam and gas emissions raises questions and concerns. Could these be the early signs of another catastrophic event, or are they simply part of the mountain's natural cycle? And could the rumblings of this Cascade volcano somehow reach across hundreds of miles to Yellowstone, the sleeping giant? The interconnectedness of geological systems means that activity in one area can have far-reaching effects. The possibility of a link between Mount St. Helens and Yellowstone adds another layer of intrigue to the unfolding story. The questions linger, fueled by the unknown. As scientists continue their vigilant watch and the public remains fascinated, the mountain stands as a testament to nature's unpredictable power. What lies ahead is uncertain, but one thing is clear. Mount St. Helens will always be a symbol of both destruction and renewal. The notion of one volcano setting off another sounds like a plot from a sci-fi movie. But could this seemingly fantastical idea have a basis in reality? Picture a world where the Earth's crust is a fragile network of interconnected systems, each capable of profoundly influencing the others. This is the domain of geology, where the improbable can become possible. In this captivating field, scientists have long examined the complex interplay of tectonic plates and the immense forces driving volcanic activity. They have found evidence suggesting that the eruption of one volcano can indeed trigger a chain reaction, awakening other volcanoes. History tells of volcanic chain reactions, where the eruption of one fiery peak sets off a series of events, stirring others from their dormancy. These chain reactions are not mere myths, they are documented occurrences that have shaped our planet's landscape over millennia. Scientists highlight examples like Mount Pinatubo in the Philippines, where an earthquake is believed to have contributed to its massive 1991 eruption. This event was not isolated but part of a broader pattern of seismic activity influencing volcanic behavior. In Italy, the volcanoes of Etna and Stromboli, though miles apart, have shown synchronized activity, their eruptions seemingly connected by unseen forces. This synchronization suggests underlying mechanisms linking these distant giants, allowing them to influence each other in ways we are just beginning to understand. These examples, while localized, hint at the interconnected nature of volcanic systems. Studying these connections is crucial as it helps scientists predict future eruptions and understand the broader implications of volcanic activity on our planet. As we delve deeper into the mysteries of the Earth's crust, we may uncover even more surprising links between these powerful natural phenomena, revealing a world where volcanoes truly do collide. Mount St. Helens is part of the Cascade Volcanic Arc, a series of volcanoes extending from British Columbia to Northern California. Formed by the collision of tectonic plates, the Cascades showcase the tremendous power of the Earth's internal forces. As the denser oceanic plate sinks beneath the continental plate, it melts, producing magma that ascends to the surface, powering the fiery eruptions of the Cascades. Mount St. Helens, relatively young in geological terms, exemplifies the explosive potential of this volcanic arc. Chapter 5. The Yellowstone Giant. Yellowstone is an entirely different entity. It rests on a colossal caldera, a collapsed volcanic system that far exceeds Mount St. Helens in both magnitude and strength. This supervolcano is driven not by tectonic plate collisions but by a mantle plume, a column of hot rock ascending from deep within the earth. This plume functions like a blowtorch, melting the overlying rock and forming a vast magma reservoir. Eruptions at Yellowstone are not just explosions, they are monumental events that can reshape entire continents. Section 6. Fire and Fury, Worlds Apart. The geological contrasts between Mount St. Helens and Yellowstone are immense. Mount St. Helens is driven by subduction, while Yellowstone is fueled by a mantle plume. Their magma types are different, their eruption behaviors are unique, and their potential impacts vary greatly in scale. Mount St. Helens eruptions, though powerful, are confined to local areas. In contrast, Yellowstone's super eruptions can have worldwide effects. Chapter 7. Whispers Across the Miles. The question arises, could the activity at Mount St. Helens somehow set off Yellowstone? Scientists agree that the answer is a definitive no. These two volcanoes, separated by hundreds of miles, have no direct connection. Although seismic waves from a major eruption at Mount St. Helens might be detected at Yellowstone, the energy would be insufficient to trigger an eruption. The Earth's crust acts like a massive shock absorber, dispersing energy over long distances. Chapter 8. Sentinels of Stone. Although there's no direct link, scientists keep a close watch on both Mount St. Helens and Yellowstone. Seismometers record every tremor in the Earth, while GPS stations monitor ground deformation, and gas emissions are checked for changes in their composition. These stone sentinels offer crucial data, enabling scientists to monitor volcanic activity and issue early warnings of possible eruptions. The 1980 eruption of Mount St. Helens serves as a powerful reminder of nature's force, leading to advancements in monitoring techniques and preparedness strategies. Chapter 9. The Earth Breathes. Our planet is a living, breathing entity, constantly in flux. From the movement of tectonic plates to volcanic eruptions, the Earth is always active. These transformations, often slow and subtle, shape the world we know. The landscapes we admire today are the result of millions of years of geological activity, showcasing the Earth's relentless energy. Volcanoes, with their fiery outbursts, exemplify this dynamic nature. They serve as the Earth's release valves, expelling energy from deep within. When a volcano erupts, it starkly reminds us of the powerful forces beneath our feet. The molten lava from these eruptions can create new landforms, continually reshaping our planet's surface. Although the chance of one volcano triggering another across great distances is minimal, it isn't entirely impossible. The interconnected nature of geological processes means that an event in one region can have ripple effects elsewhere. This interconnectedness highlights the delicate balance within the Earth's systems. The Earth operates in mysterious ways, and our understanding of its complex processes is ever evolving. Scientists are continually uncovering new insights into how our planet functions. Each discovery adds to our knowledge, helping us better comprehend the intricate workings of the Earth. The more we learn, the more we realize how much remains to be discovered. Our best approach is to heed the Earth's subtle signals, to monitor its every tremor, and to prepare for what lies ahead. By studying seismic activity and other geological phenomena, scientists provide crucial insights that help us prepare for natural disasters. This knowledge is vital for safeguarding lives and property. In the face of nature's immense power, knowledge and preparedness are our strongest defenses. Understanding the Earth's processes enables us to anticipate and mitigate the impacts of natural events. Through this understanding, we can coexist with nature's powerful forces, ensuring a safer and more resilient future for everyone.